Hi folks, it's week 3 in astronomy. And this week it's all about celestial navigation. Celestial navigation is how do you figure out where things are in space when everything's moving. The Earth is rotating as we are moving around a sun, and the sun's rotating around the center of the galaxy, and the galaxy is in motion across the universe. It is very complicated. So how do you create reference points, and how do you travel from point A to B and measure things? That's why we're going to talk about celestial navigation. One thing to keep in mind, what I'm calling week 3 is actually mostly chapter 4 in your textbook. So when you look at that study guide, please watch carefully the book's chapter and section numbers, because it's not even all of chapter 4. So let's take a tour of Canvas and let's talk a little bit about our lab. So for this week, let's go back to the entire module 3 for an overview of what we're up to. We're going to start with celestial navigation. As I mentioned, that study guide, remember that's a reading guide. There's no way I can teach you everything in a couple hours worth of lecture, and that book is your second instructor. Pay attention to the pictures, but what I highlight in the study guide are the things that are the most important. That's why that's there. Right ascension, declination, altitude, and azimuth. These are methods of determining where things are in outer space. So we're going to spend a lot of time talking about that. But we're also going to talk about the calendar and seasons. What we measure time with on Earth, from years to months to days, all have to relate back to the sun and the earth and the moon and the solar system. So we're going to talk about the origins of those, and equinox. Equinox means equal night. Those spring and fall equinoxes. Then we're going to get into our celestial navigation lab, which we'll talk in detail about in a moment. Remember, weekly we have constellations that are fair game on our quiz, and we have our quiz every week, our 10-question, 20-point quiz. One of the things that we're going to talk a little bit about on this week's constellations, besides the little video on constellations, there's also going to include a link to the observation project. The observation project, ladies and gentlemen, is a project that is going to be due at the end of the, towards the end of the term. And so when you look at this week's information on constellations, there's a link back to the module that's right after module 1. It contains the information about constellations, but information on that observing project. Check to the individual schedule for this semester to know exactly when that's due, but you do need to get a start on that. And there is a special video just explaining that observation project. So I'm not going to go into it in great detail here. You will get reminders on this throughout the entire semester. So let's talk about this week's lab, Celestial Navigation Lab. First part of the lab is I want you to spend some time with latitude and longitude, which is very terrestrial, which is very earthbound. But why do we spend time with it in an astronomy class? The reason is because if you understand this, right ascension and declination will be easier to understand, because when astronomers were trying to map the sky, they started with something they knew, and that was latitude and longitude. So the same techniques were used in the heavens. So we're going to start with the Earth. Go back to our notes and what we've talked about. You may need a globe or a map of the Earth that you can find online. Please draw these on this. As always, I highly recommend some colored pencils to help make things pretty. And if you do that, scan the lab in after you've printed it. It's probably the easiest way to attack this. I want you to read this map for latitude and longitude and find Eau Claire, Wisconsin, and see if you can read the latitude and longitude. After you're done, go online, find the official latitude and longitude of Eau Claire, and see how close you were. Then on this map down below, just using latitude and longitude can you find these locations. probably pretty good idea geographically where some of these places are, but can you use latitude and longitude to find a location? This is practice for right ascension and declination, which is coming up. Speaking of right ascension and declination, okay, let's review some words from the notes, and then let's practice these, because I think this is a tricky skill to learn, is right ascension and declination. Declination is how far up and down. So I'm going to ask you to sketch some of this, and then it gets trickier because you and I do not live on the equator. We live at a different latitude than the equator. So because of that, you and I, where we live in the middle to upper part of North America, we see positive and negative declination. So I want you to mark these on this picture, positive and negative declinations. Can you figure out where those should go on this picture? Right ascension is left and right. So I want you to convert hours to degrees. Why is this useful for astronomers? In 1 hour of time, a star will move 15 degrees of arc. Remember when we were moving things with our hands in past lessons of how far something will move in about an hour? It's really useful when you are out observing stars. So do this simple little bit of math to convert these common amounts of time. And then on this globe, I want you to draw these shapes. Can you then put it all together and mark when these right ascension and declinations are going to go? Now, altitude and azimuth are different. Altitude and azimuth are a second way of locating something in the heavens. Again, review back to your notes. The labs are always designed to occur after you've learned the information in the notes. They're designed to reinforce it and help you practice it. So I want you to take a look at these altitudes and azimuths and see if you can tell me what direction would you look and how high above the ground would you look. I want you to go to the University of Nebraska simulation. This one has to do with altitude and azimuth demonstrator, and you can put those altitudes and azimuths in there. You can take this little slidey bar and go to different azimuths, and you can put the little star at different altitudes. You can either do it with this, or you can physically, with your mouse, move the star around up here. But this is real helpful to help you visualize and understand those concepts of altitude and azimuth. As always, when we are using any of these simulations from the University of Nebraska that require Flash Player, you may have some challenges, and remember, you might have to change browsers or allow Flash Player. Now, diurnal motion. Diurnal motion is daily motion. There are daily motions that we observe, and this is due to the Earth's motion. And because of our motion, we see the sun appear to move. It does not. We're the ones who are moving and rotating, and this is what we see. So again, refer back to your notes and see if you can determine where on planet Earth you would see these patterns of star motion. Go to the Stellar Star Motion Simulator. Again, this is the address from University of Nebraska, Lincoln. And when you go to the Stellar Star Simulator, I ask you to turn some things on. Turn on show labels, turn on showing the Big Dipper and Orion and the Southern Cross. And then I always so like to turn on long star trails. And then you can start the star trails. And when you start those star trails and start the animation, you can kind of see the daily or diurnal motion. You also need to put our position here for where we are on planet Earth. You can type in latitude and longitude. Where do you get that? Well, back in the beginning of the lab, you had to type in the latitude and longitude of Eau Claire, Wisconsin, and you can certainly type that in right there. Then follow the little questions and see how that goes. The rest of the lab, you're going to be using that planisphere. That planisphere was that special piece of equipment I asked you to buy from the bookstore. And please watch, included with this lab, there is a short video I made on just how to use the planisphere. The planisphere is cool. There's lots of nifty information on it. This is an introduction to it. I just want you to put you through your paces, get you using it, get you finding some information about it. And please watch the video that I made on how to use a planisphere. I think you're going to really love it. It is a cool thing once you get to know it. So that will do for this week. Lots of good stuff. Remember, we're reading chapter 4. Even though we're in week 3, it's okay. We don't have to be at exactly the same numbers. It's all right. You have a fabulous week. Let me know if you have any questions, and we'll talk to you soon. All right? Bye-bye.